We have just reached the last section of Math 005. So we are going to be talking about slope and rates of change. There's a lot of information in this section, so I would definitely take some notes. So the objectives here is just to talk about what is slope, recognize positive, negative, zero, and undefined slope. That's pretty important to be able to do. Find slopes of lines, and then understand slope as a rate of change. So first we're going to look at introduce slope and talk a little bit about what it is. So given the following graphs where the x-axis each time is time. Okay, so imagine the x-axis is time. Which graph might represent the distance traveled by you if you were walking at a constant rate? So you're just moving along at a constant rate, and something that the other axis is distance. So what that means is you've got a graph, this side is time and this side is distance. So the distance would be changing at a constant rate. So I would say that would be B. Okay, so in B, if you have distance here and time here, then you would have a constant change if you're walking at a constant rate. So it would be a straight line. Which one represents the temperature in your freezer over time? So in that case, you would have time here and temperature here. I wrote it out because they're both T's. Temperature here. So you don't want the temperature in your freezer to change at all. So hopefully we're talking about this one here. So this is temp and this is time down here. And of course the temperature is below zero. So it's like negative, 40 or something like that. Okay, so that one would be C. The value of a laptop computer after it's purchased. So all we have left is this one. So this is going to be its value or dollars, and this is time, and it's going to go down. So that is A. So we're going to start looking at measuring slope. And so we're looking at a stairway because it makes it a little bit more obvious. The slope of a stairway, so when you're in construction, you have to figure out the slope for various things. And this is one example. So if you look at each step, it should be consistent. You've got a rise of 6 inches and what we call a run of 12 inches. So I think this is typical stairs right here, and everyone is consistent. So if you drew a line from the tip of the step all the way up, the slope would be 6 over 12. The rise over the run. So I have a question, and that is, where else in your life do you care about slope? So if you're in construction, of course, you're going to care about it in a number of ways. Anytime something goes up, a roof, stairs. When you're building a driveway, do you want it to be really steep? Probably not, in which case you might, if you have a steep hill, have to go at an angle up the side of the hill. If you ski, you might care about the slope. A road, there's all sorts of things. So think about the things where you care about slope and kind of try to think about slope in a real life situation so that it makes sense to you. So next we're going to look at recognizing positive, negative, zero, and undefined slopes. So we're going to let the letter M represent the slope. So we're using M to represent the slope. So just scan across these and look at the character of the slope for each one. So this first one, it rises from left to right. So that's going to have a positive slope. So you always want to kind of read the graph from left to right. This next one, it's going to fall from left to right, and that means it has a negative slope. So we're going to be looking at rise over run, and so if the rise is 0, then it has a 0 slope. But if the run is 0, so this has a 0 slope right here. Okay. But if the run is 0, then it has a slope of undefined because the run is in the denominator, and we don't like the denominator to be 0. It makes it undefined. So a horizontal line has a 0 slope, and an undefined slope is the vertical lines. So in general, to find the slope of a line, here we've got the cost of parking, so time, which is always on the x-axis, and the cost is over on the y-axis. So to find the slope, you're going to just pick any point that's like, on a crosshair, and you're going to find another point that's on the crosshair, and you're going to say rise 1, 2, run 1. So we end up with 2 over 1. And you can pick any two. They picked these two right here. But that's how you find the slope. So here's a little bit more information about finding slope. So any two distinct points on a non-vertical line can be used to find the line slope, because remember, a vertical line is undefined. So M is going to be the rise over the run. That's what we often say, which means change in y over change in x, which sometimes is written change in y over change in x. So those are triangles. It means delta or change. Change in y can be represented as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you need to make sure, so if you look over here, here's our point 2 and our point 1. So those two, point 1 has an x sub 1 and a y sub 1. Point 2 is an x sub 2 minus a y sub 2. So if you look here, you see that the change in y is the distance from the first point to the second, and the change in x is the distance, horizontal distance from the first point to the second. So that is called the run. Rise and run. And we can do that just from the points without graphing. So the rise is found by calculating the change in y, and the run is found by calculating the change in x. So here's our equation that you need to have in your notes. The slope, m, of the line passing through these 2 points, x1, y1, and x2, y2, you can also say x sub 1, y sub 1, is m equals rise over run equals y sub 2 minus y sub 1 over x sub 2 over x sub 1. I would have that in your notes somewhere if you don't have it in your head. All right, so by looking at the x-coordinates of 2 points on a line, how can you tell if a line has an undefined slope? In other words, if it is vertical. So take a moment and think about that. So the answer to that is that x is the same. It's unchanged. X is the same in both. So it is a vertical line going this direction because x doesn't change. X is the same here, here, and here. Okay? All right, so next we're going to find the slope of a line. So let's look at this example. All right, so we'll call this one point 1 and this one point 2. So m equals the change in y over the change in x. So we've got y2 minus y1, and you need to do it in the same order. If you do this in a different order, you're going to get a negative slope from what it is. So if it's positive, you would get negative, and if it was negative, you would get positive. So be careful. So we're going to call y2 0.2, so that's going to be negative 1 minus y1 is 1. 0.2, I made a mistake, so I want to fix that real quick. Okay, I had accidentally put a 2 right there, and it needs to be a 1. So make sure you make that the right thing there. All right, so now we've got x2 minus x1. Now here's where people often mess up. Make sure you pick these in the correct order. We called this one right here 2. Okay, so we need to put that one first. So x2 is 3. x1 is the other x value, and that's negative 3. So be careful with your negatives, use parentheses. Negative 2 minus 1 is negative 3. Negative 3, or sorry, 3 minus negative 3 is going to be 3 plus 3, right? 3 plus 3, so that's 6. So we get negative 1/2 is the slope. So first double check that you got the right sign on that. So the sign is negative, and it is a negative slope going downward to the right. All right, so negative 1/2. What if we had picked 2 different points on this line? So at this point, I would like you to try this one. Pick 2 different points on the line, and this is the you try it part, and see if we get the same slope. You should get negative 1/2. So pause the video and give it a try. Find 2 other points on the line. Okay, so you have to look for points that are right on the crosshairs, so they're not off a bit. So this one right up here would have been a little hard to use because you can't tell exactly what it is. So find them exactly on the crosshairs. So this one is negative 1, 0. That's 0.1, so I called it x1, y1. 0.2 is 1, negative 1. I plugged those into the formula for slope, and I got negative 1/2. Okay, so this next one we're supposed to calculate a slope from 2 points. I will do the first two and I'm going to have you do the last one. All right, so slope for this first one is going to be change in y over change in x. So y2 minus y1 over x2 minus x1. If you get your y's and x's confused, I would recommend writing that down for a little while. So the second one, y value minus the first y value over the second x value minus the first x value. And I get negative 2 over 2 minus a negative is 4. So I get negative 1/2. So now we're supposed to graph it and see that really looks like what it is. So negative 2, 3. So negative 2, 3 would be right there. And 2, 1. So we get 2, 1. And it does look like we're going to have a line that goes, I've got my ink to shape on there and it makes lines for me, but it doesn't always do a perfect job. So it should have arrows on either end, but we've got negative 1/2, which is what that looks like. So make sure at least the positive and negative lines up. All right, so let's try another one. B is going to be m equals, and I'm going to run out of space, so I'm going to skip the y2 minus y1, but I'm going to take the second y value minus the first y value over, now I already see 0 is going to be on top, so I could probably stop there, but I'm going to keep going, 2 over, or minus negative 1. So I get 0 over 3, which is just 0. All right, so let's see if this is a horizontal line, because a slope of 0 is a horizontal line. So negative 1, 1, 2, 3 right here, and then we get 2, 3, and yes, that is definitely a horizontal line. All right. Okay, the last one I'm going to let you try, so pause the video and give it a shot. Okay, so you should get negative 5 over 0, so that is an undefined line, which is a vertical line. So then you go to graph it and you see that it is definitely a vertical line. Next, we're looking at finding a slope from a graph. So we just want to look at the graph and find a couple of points on here where it crosses exactly at the numbers that we're looking at. So we're going to go from 10, 20, 30, 40. So that means the change in y, it goes from 10 to 40. So we're going to do that. And the change in x goes over here. So we've got the change in y and the change in x. The change in y looks like it is just 10. Just going from 10 to 20. So we get 30 over 10, which is 3. So the slope is 3. All right, this next one is a horizontal line. So the slope is 0. Okay, this next one, we need to sketch a line that passes through the point 1,4 and has a slope of negative 2/3. So now we're taking the slope and drawing it. So the point 1,4 is going to be here. All right, now it has a slope of negative 2/3. That means we either have, so if m is, and this is the trick to negative slopes, so make sure you understand this. Either the rise is negative, which means it goes down instead of up, or the rise is positive and the run is negative. So this means up, this means right, and this means left. Okay, so be really careful with that. So we start here at the point and we go down and to the right or up and to the left. So down 2, 1, 2, and to the right 3. 1, 2, 3. Okay, so that would be the line passing through, passing through those 2 points. It has a slope of negative 2/3. Okay, so these are, the negatives are hard for people. Don't make them both negative because then it's a positive slope. Okay. All right, so now you get a chance to try it. This one has a positive slope. So give this one a try. Pause the video, sketch it out, and see if you get it right. Okay, so I started with my point, -1, -3, right over here, right there. And then I used the slope 1/4, so I wanted to make note that 1 means up 1 and 4 means right. So if they're positive, they're up and right. If they're negative, they're either left or down, but not both. All right, so I went up 4 and over to the right, sorry, up 1 and over to the right 4. Okay, this next example is very different, completing a table of values from the slope. So this requires an understanding of slope itself. So it's saying that this has a slope of 2, and it passes through this first point. And so then what does it do from there? All right, so if it has a slope of 2, that means it has a slope of 2 over 1. Because remember, 2 is just 2 over 1. So that means the 2 is the change in y, and the 1 is the change in x. Okay, so that means if x is going plus 1, plus 1, plus 1, and this is positive, then that means that the change in y is 2, and it also has to be positive. Okay, so we're going to have plus 2, and then again plus 2, and again plus 2. So that's a straight line. So we're going to have 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So that's how you fill out a table from the slope. Okay, so we are going to talk about understanding slope as a rate of change. It's important to understand that slope measures the rate of change of a quantity. That's what slope does. So our example here is interpreting slope with this picture right here. So the first thing you need to do before you even look at any questions is interpret the graph. So on the bottom here I've got time in hours. So 0, half an hour, 1, 1.5 along the bottom. Over on the right, on the left side, on the y-axis, we've got distance in miles, 10, 20, and 30. And up here, we've got distance from home. Okay, so we need to make sure we understand that we are looking at distance from home. Okay, so in A, we're asked to find the y-intercept and what it represents. So the y-intercept is going to be 0, 20. So 0 is the time, and 20 is the distance. Okay, so at time 0, at the start, we are 20 miles from home, because it says right up at the top, distance from home. So 20 miles from home. All right, B, the graph passes through the point 110. Discuss the meaning of this. Okay, that's this one right here. Okay, so 110, again, 1 is 1 hour. So at 1 hour, we have 10 miles. What does that mean? Well, they're 10 miles from home. It's that simple. All right, so then the last question, take a look at that and think about it for just a moment. Find the slope of the line. Interpret the slope as a rate of change. Okay, so the distance from home is going to be used here. Well, let me rephrase that. We're going to use the slope to figure out basically distance per time, because remember that slope is change in y over change in x, which is the change in distance over or per the change in time. Okay, because that's what we have on the x and y axes. So change in distance per time, well, that is speed, right? Change in distance per time, like miles per hour, that's speed. So if we look at the change in y here, we can pick any 2 points, it doesn't really matter. So I'll pick the top one and the bottom one, the 2 intercepts. So we get the change in y. So let's see, let's go ahead and write the 2 down just to make it really clear. So we've got one intercept that's 0, 20, and the other intercept that's 2 and 0. 2 and 0. So we get 0 minus 20, and we get 2 minus 0. So we get negative 20 over 2, which is negative 10. Okay, so that the negative just means they're getting closer to home. Closer to home. All right? So toward home at 10 miles per hour. And that is how you use a graph to get a rate of change. Okay, we have a completely different kind of problem here to interpret slope. When a company manufactures 2,000 MP3 players, its profit is $10,000. When it manufactures 4,500, its profit is $3,500. And you could graph these, but we're just being asked to find the slope of the line. So we don't need to graph it. So we've got, this is going to be x1, y1, and x2, y2. So we're going to find that the slope is going to be y2 minus y1 over x2 minus x1. So y2 is 35,000 minus 10,000 over 4,500. Make sure you go in the same direction so you use the same coordinate pair. So we've got that one as the first one, and the second one is 2,000. So we're going to get 25,000 over 2,500. And that gives us 10. So that is the slope. So interpret the slope. So this was A. B asks us to interpret the slope. So when 2,000 to 4,500 MP3 players are manufactured, profit on average is $10 per player. So that's what this means. So the profit is $10 per MP3 player. And sometimes you have to draw it out to figure that out. All right, we've just got one more left. Okay, this is my last example. Application of slope to a line graph. So this one was a little bit weird, and I wanted to show it to you. So this table lists the number of reported cases of tetanus in the United States for these years. So they first ask us to make a line graph of the data. So what that means is this isn't a perfect line. It's not a scatter plot, it's a line graph. So instead of spending the time to do this, I just decided to have it done ahead of time. So we've got year, of course, time always goes on the x-axis, and cases of tetanus should go on the y-axis. All right, so all of these m's are the different slopes. So as you can see, every single one of these has a different slope, and they're asking us to find the slope of each line segment. So I'm going to do the first one for you, and then I'm going to pause the video and get all the others on here. So the slope of each line segment needs to be done separately. So M1 is going to be from 1960 to 1970. So I'm just looking at these right here. So the y-axis is, remember the year is x and the cases of tetanus is y, so be careful. So I'm going to have 148 minus 368. So yes, we're going to get a negative number, so be careful. And 1970 minus 1960. Okay, so we get, when you put this in your calculator, you're going to get negative 22.0. Okay, so for the next one, we're going to use, We're going to use 1970 to 1980 and 148 to 95. So we get 95 minus 148. And that's going to be over 1980 minus 1970, which is just 10 years. Every one of these is 10 years. So I'm just going to start putting 10 on the bottom because it makes it simpler. And we get negative 3.1. So as you can see, the slope is getting to be a little bit less. All right, so the next one that we're going to look at is this change right here. And we get 64 minus 95 over 10. And I'm going to pause the video now. After I write this one down and write the others down, and then we'll go on. Why don't you pause the video as well and try to do the next two and see if you get the same answer. And then go ahead and try to answer C and see if you can interpret each slope as a rate of change. Okay, so what all of this means is the decrease from 1960 to 1970 was negative 22, and then each one of them were found to be, the others are found to be fairly similar decreases. So to answer C, the number of cases decreased on average every 10 years. The biggest decrease was 1960 to 1970. All right, thanks for watching.